Another topic that ends up being related to rational functions is comparing direct variation, which we've seen before, y equals kx, and we know how to graph that and all these things. Comparing that to inverse variation. And you can see there's actually a pretty fundamental difference in the setup here. Direct variation is y equals k times x. Inverse variation is y equals k divided by x. And in some ways, looking at them in a different format actually is a little bit more useful. So if we look at this version of direct variation, it says direct variation means that two things have a constant ratio. You always get the same thing when you divide them. Inverse variation, again, all I'm doing here is in this case, I've divided both sides by x. In this case, I've multiplied both sides by x to get k by itself. So inverse variation says that two quantities have a constant product. In direct variation, when one went up, the other went up. When one went down, the other went down. Inverse, well, now we kind of get why they use the name inverse. If x goes up, y goes down. If x goes down, y goes up, and so on. And so inverse variation means that two things have a constant product. One vocab thing, actually two vocab things we should talk about. First, this meaning of inverse here is different than when we're talking about inverse functions. It's just two different uses of the same words. The other thing we should talk about is just how we say these things. In a sentence, for direct variation, we would more easily say y varies directly with x. Sometimes we say y varies directly as x. It's just a terminological thing. They mean the same thing. And with inverse variation, similarly, we could say y varies inversely with x. We could also say y varies inversely as x. I'm not sure why we say it that way. It's just a thing that we say. And mostly what we want to be able to do with these is to take these descriptions and write them as equations. So we'll just do that with 4 examples here. First one says y varies inversely as the square of x. So remember, inverse format means we're talking about something that's in a denominator. So we're going to write y equals, the denominator is going to be the square of x. And then with all these, we're always going to have some constant. So whatever that is, this means that as the square of x gets bigger, y gets smaller. Or if we want to put it in that other format that we discussed, it would look like this. Another way of thinking of this is that y and the square of x have a constant product. And that's what this says. Okay, second one, y varies directly as the root of b. So direct would be numerator. So directly as the root of b, and inversely as the cube of a. So the inverse part goes on the bottom. Oops, cube, not cube root. And there we go. So y varies directly as root of b, inversely as cube of a, and there's always going to be a constant. The idea of the constant is it doesn't necessarily mean that if we take y equals kx as a simple example, it wouldn't always be accurate to say, oh, y is always going to equal x. Let's say that x is the number of cups of coffee you sell and the y is the number of dollars that you make. They're just related by some constant, in this case, the price. Like for every cup of coffee you sell, you make $2.50. So that's what the constant does. It just says, yeah, in this case, as one doubles, the other doubles. It doesn't mean that they're exactly the same. Okay. So short version is anytime you're writing one of these expressions, make sure you include a constant k. All right, y varies directly with x and inversely with, that's not a good question. So I'm gonna change that. We're gonna make that with the square of a. Okay, y varies directly with x and inversely with the square of a. So that means the square of a is in the denominator. And again, a constant. The constant's always going to be in the numerator or multiplied. Technically, you could have it in the denominator. We just don't do that. Okay, last one. Y varies inversely as the cube root of x. So inverse means that that's going to be in the denominator. And our constant, which will go in the numerator. So that's the deal with setting up these equations. We just want to make sure that we can go from a description of direct or inverse variation to putting it in an equation or a formula format.